So let's start off by taking a look at the general concept of pipelining, and then we can talk about different pipelining protocols that we're going to see are going to be used by TCP. So basically we start off, we have a sender and a receiver, and the sender sends 3 packets. The first packet arrives, and the first packet bit arrives, and finally the last packet bit arrives, and then an acknowledgement is sent. Do the same thing for the second and third packet. So what happens now is, once I get that first packet acknowledgement, then I send the fourth, and then fifth, and the sixth. Had I not used pipelining, I wouldn't even have sent the second until I receive the acknowledgement of the first. So I'm already ahead. I've already increased my utilization by 3 times by pipelining, starting off with these 3 packets. So there's basically 2 types of pipeline protocols. One is called go back N, and the other one is called selective repeat. The way go back N works is a sender can have up to N unacknowledged packets in the pipeline, and the receiver only sends a cumulative acknowledgement, and it doesn't acknowledge a packet if there is a gap. So this automatically gives a sender a clue that something went wrong. The sender, meanwhile, has a timer for the oldest unacknowledged packet. When the timer expires, it retransmits all unacknowledged packets. The assumption is that this timer is set with some knowledge of the round trip time of how long it should be expected to receive a packet. If it takes too long, it assumes something went wrong, and all the packets are retransmitted. In a selective repeat, the sender can have up to N unacknowledged packets in the pipeline, and unlike in go back N, the receiver sends individual acknowledgments for each packet. The sender maintains a timer for each unacknowledged packet, and if the timer expires, it only retransmits that one unacknowledged packet. So let's take a look at go back N. So let's take a look at the details of go back N. So on the sender side, we have in each packet header, we have a k-bit sequence number, and we have a window up to size n of consecutive unacknowledged packets that are allowed. So here we have these green packets. These are packets that have already been acknowledged. We have the packets that are either yellow and blue within this window size of n. The packets that are in yellow are packets that have been sent but not yet acknowledged. The packets that are blue are usable, so we can send them, but we haven't sent them yet because we can have up to N unacknowledged packets, and we haven't reached that N yet. So we have ACK of sub n, which is the ACK of up to a particular number of all packets up to including sequence number n. These are our cumulative acknowledgements, which are basically the packets that we've acknowledged so far. Now we can receive a duplicate acknowledgement. Now also remember we have to deal with the concept of a timeout. So we have a timer that's keeping track of the oldest in-flight packet. And we're going to reach some timeout value where we have to retransmit packet N and all higher packet numbers in the window if this timeout value is reached. So looking at this from the point of view of having to make some logical decisions based on outside events, the go back N sender responds to three different types of events. One is an invocation from above, and if you recall from 475 what the RDT send is, that's basically the application saying to the transport layer, I want to send a packet. So an RDT send is called, the sender checks to see if the window isn't full. If not full, then a packet is created and sent. If the window is full, it goes back and tells the app that the window is full, or it uses some sort of semaphore to allow the app to send only when the window is not full. So in this case, I never received an RDT send request when the window is full. The other type of event is the actual receipt of a packet. An ACK for a packet with a sequence number N is taken to be an accumulative acknowledgement indicating all packets with sequence number N have been correctly received at the receiver. Keep in mind the receiver never sends acknowledgments if it has any missing packets. So if I received an acknowledgement for N, that means everything up to N can be acknowledged. And finally, there is the timeout. So like we mentioned, the receiver never acknowledges if there's a missing packet. So in that case, you would have a timeout event. So a timer is used to recover from lost data or acknowledgement packets. If a timeout occurs, the sender resends all the packets that have been previously sent but not acknowledged. And what good thing about this will cover any lost packets in that set of packets. Timer is a timer for the oldest transmitted but not yet acknowledged packet. If an acknowledgement is received, but there are still additional transmitted but not yet acknowledged packets, the timer is then restarted. If there's no outstanding unacknowledged packets, means everything has been acknowledged, there is no need to have the timer. So therefore, at that point, the timer is stopped.